The other type of inequalities we need to be able to solve are what we call compound inequalities. There are two types of compound inequalities. There's compound inequalities that represent an OR situation. So with an OR situation, we're going to have two separate inequalities. We'll have the word OR in between. We're going to solve each of them individually and then graph them together. And what it means is that our solutions can satisfy either of those inequalities. And remember, in an OR situation, our graph is going to look something like this. The other type is the AND. With AND, we can have two inequalities separated by the word AND, but more likely we're going to have one inequality written with what I call three pieces. Essentially, you're going to have the expression in between two other numbers with inequalities. When we have the three pieces, instead of solving each piece individually, we're going to isolate the variable in the middle by going through our solving steps and making sure that if we do something to the middle, we also do it to the left and the right. And whereas with the OR, my solution can satisfy either inequality, with AND it has to satisfy both. My graph is going to look something like this. So there's three examples where we're going to look at solving compound linear inequalities and looking at their graphs. So I'm going to jump to the first one. And I see this is an OR situation, so I'm going to solve each of these individually. So solving the one on the left, I first distribute, giving me 2x plus 2 minus x is less than negative 3. Combining like terms on the left side of my inequality, 2x minus x is x, plus 2 is less than negative 3. Now I can go ahead and get rid of the add or subtract by subtracting 2. And I end up with x is less than negative 5. I also have to solve the other piece, so I'm going to drop my OR down. And looking at the other side, there is no distributing, there are no like terms, and the variable's already on one side. So I'm going to go ahead and get rid of that minus 4 by adding a plus 4 to both sides, giving me 3x is greater than or equal to 5. Dividing both sides by 3, I get x is greater than or equal to 5/3. So here are my two solutions. I'm going to go ahead and graph them on the same number line. I know, just like before, 5 over 3, I know that that's the same thing as 1 and 2/3. So I'm going to go ahead and put a negative 5 on my number line. I'm going to put a 1 and a 2. I'm going to put an open circle at 5. And reading the variable first, x is less than negative 5, so I shade to the left. Then I also have a closed circle at 1 and 2/3. So just before the 2, between the 1 and the 2. And if I read the variable first, I have x is greater than or equal to 5/3. So I shade to the right. And there is the graph that corresponds with my solution. So again, with OR, I solved each one separately and graphed them together. My next example is an AND situation. I know it's AND because I essentially have because I have this one inequality with kind of three pieces, so to speak. I have my left side, I have my middle, and I have my right side. Notice sides are determined by the symbols once again. So I'm going to work the middle. So in the middle, I see I can distribute. So I'm going to leave the left. I'm going to leave the right. I also see in the middle I have like terms, so I'm going to combine those, giving me 2x minus 3 in the middle. And now, just like I've done before, I'm going to go ahead and work to get that x by itself. But now, instead of getting it by itself on the left or the right, I'm going to get it by itself in the middle. So I'm going to add 3 to each piece, because I get rid of add or subtract first. I get 1 is less than or equal to 2x, less than 10. And then I'll get rid of multiply by dividing by 2, so I also have to do that to the left and to the right. Doing that gives me 1/2 is less than or equal to x is less than 5. Since x is by itself in the middle, I've found my solution. Now I want to graph it, so I'm going to go ahead and draw my number line. So 1, maybe I'll start at 0 actually, 1, and then 5 would be somewhere up here. So 1/2 is going to be a closed circle in the middle of 0 and 1. I'm going to shade x is greater, because I read the variable first. X is greater than or equal to 1/2, so I'm going to shade to the right. and x is less than 5, reading the variable first, so an open circle at 5, and I shade to the left, and notice because it's an and, as you've seen up above, and as you've seen before when graphing, and I have to be in the middle. So there's going to be my graph that corresponds with my solution. Looking at one final example, first thing I'm going to do is notice that I have 3 parts. So again, I'm going to go ahead and say I have a left side, I have a middle, and I have a right side. So I'm going to go ahead and work the middle so I can get it into a position where I can add, subtract, multiply, or divide to get x by itself. So I'll start by distributing the -3. Everything else comes down. Now I have like terms in the middle, so I'm going to combine my like terms. From here, I'm now ready to start getting that x by itself, so I'm going to get rid of add or subtract. So I'm going to go ahead and get rid of this 2 out here that's not attached to the variable. So I'm going to subtract 2, and subtract 2, giving me 12 is greater than negative 3x, because sign belongs to the number it's in front of, greater than 2. And now I can go ahead and divide by that negative 3. Oh, and actually, I see I have a mistake up here. So I'm going to correct my mistake. Negative 3 times negative 1 right here when I distributed it should have been plus 3. 3 times 1 is 3, which means when I combine my like terms of 1 and 3, I would have gotten 4, not 2, which also means I should have subtracted 4 from the left, 4 from the middle, and 4 from the right. So my inequality would actually read right now, 9 is greater than negative 3x, which is greater than 0. So take a moment and fix that in your notes. Now to get x by itself, I'm going to go ahead and get rid of that multiplication by dividing all pieces by negative 3. And I remember that when I divide or multiply both sides by a negative, my inequality flips. So that becomes negative 3 is now less than, x is now less than, 0 divided by negative 3 is still 0. Graphing that, it is an and statement because it is one equation or one inequality. So I should be in between two numbers. And doing that, I get an open circle at 3. And reading the variable first, x is greater than negative 3, so I should go to the right. An open circle at 0. Reading the variable first, x is less than 0, so I should go to the left. So I do, in fact, stay between those two numbers, just like I predicted. So once again, I apologize for that error I had in that third example. I really hope that didn't throw you off too much, and I hope I caught that soon enough where you're able to edit that in your own work. Bring in any questions you have with you to class, where we'll do some more practice with solving inequalities, both inequalities that are not compound inequalities and compound inequalities.